In a castle defender game, a cannon throws a cannonball with the initial velocity of 100 meters per second, okay? Actually, it should say speed here because our velocity doesn't provide any information about the direction. Actually, it will in a moment, okay? So I have the right to call it velocity. What is the distance in which the ball would touch the ground? And what is its maximum flight altitude if the inclination of the barrel to the ground, barrel is the part of the cannon that you use to shoot, okay, is 30 degrees, okay? So we know now everything about velocity. Velocity magnitude is 100 meters per second, and velocity direction is 30 degrees. So is it working? Yes. Pen mode. So the situation is like this. This is the ground, okay? Let's say that the cannon is here. And just for simplicity, I know that the cannonball normally starts like a meter above the ground, okay? But for simplicity, we will assume that the cannonball starts exactly at the level of the ground. And it has its initial velocity, which looks something like this. That's the initial velocity. It's a vector, of course. And we know that here is 30 degrees. Okay? And now, what we are first of all interested in, it's in the vertical and horizontal component of this velocity, because both, first of all, both of them are responsible for different things, and they are very much different in nature. So as I mentioned before, the vertical component is accelerated motion, sorry, it wasn't very vertical, okay? And horizontal is a constant speed motion, okay? So I will switch the color. Horizontal component is here, and I will call it, sorry, I don't remember what, I used the letter H, okay? I used two different styles of calling this variable. It could be either V with the index X, okay, as the direction, velocity in X direction, or just horizontal, okay? Whatever you use, it just cannot be just V, because it would be very confusing. Okay, so this is my horizontal velocity, and I will now try to draw my vertical velocity. This is the vertical direction, okay, and this is my vertical velocity. You can notice that because this is a rectangle, this vertical velocity is also the value of this edge of a triangle, okay? And this should give you an immediate hint that both values of vertical velocity and horizontal velocity we can get from trigonometry, okay? So in both cases, this will be the value of V, not a vector now, because I'm just taking my value 100 meters per second, so magnitude of this vector, multiplied for the vertical velocity. Which function is it? Sine, cosine, tangent? Sine, very well. Yes, thank you. Sine, because the main velocity is the hypotenuse, and my vertical velocity, which is here, but also here, okay, it's not adjacent, it's the opposite, okay? So it's sine. I will call this angle alpha, but we know that this is 30 degrees. And of course, the horizontal velocity, it is 30 degrees here at the adjacent edge, so it's cosine alpha. And it is not shown here, but sine 30 degrees is 0.5. So we get 50. And cosine alpha, you will get, if this was a in-class test question, you would get information that you should apply the value of 0.87 as the cosine times 100, it's 87 meters per second, and here meters per second. And these are very important initial calculation. Because what we now know, the vertical velocity is like I was throwing something upwards, okay, like this, with the initial speed 50 meters per second, okay, and we can nearly immediately find the solution for the first part, no, second part here. What is its maximum flight altitude? Okay, so the question basically is, if in vertical direction I started with 50 meters per second, okay, what is the maximum point? Okay, so it's basically as simple as, if I have something here, I drop it, okay, and at the end it has 50 meters per second. What was the altitude? So I'm using typical motions for accelerated motion. For example, the velocity, in this case, this is the vertical velocity, is acceleration times time. That's the formula used by us previously. Okay, in this case, this acceleration is gravitational acceleration, so this is GT. All right. From this formula, we can find T as vertical velocity divided by G, and vertical velocity is 50 divided by 10. We get 5 seconds. Okay, I know that we need distance. Okay, but to find the distance traveled in 5 seconds, what we needed was to first find the time, because this distance, so distance in accelerated motion, it's acceleration times time squared. So we need this time. Okay. All right. So the first calculation was 50 meters per second. It's decelerating 10 meters per second, so it will get to standstill in 5 seconds. 50, 40, 30, 20, 10, 0. Okay, 5 seconds. That's our time. Please note that this is the time of ascent, and because this movement in ballistics is symmetric, it's also time of descent. So it's 5 seconds and 5 seconds, 5 seconds up, 5 seconds down. Together, what's the time of the flight of the cannonball? 10 seconds, yes. But our maximum distance in whatever it is, flight up or flight down, it's symmetrical, so whatever we calculate will be good. We need just single time, so for example, ascent time. So this calculation will be gravitational acceleration, which is 10. I know it's 9.81, but in this exercise it's 10, times 5 squared divided by 2. 5 squared is 25 divided by 2. It's 250 divided by 2. It's 125 meters. Okay. Remember, this is a cannonball. It's quite fast, 100 meters per second. So this result is absolutely realistic. A real cannonball would be just slightly below this altitude, because of aerodynamic drag. Okay, so it would be slowing down all the time, but it would be probably around 115, 118, something like that. Okay, in the real life scenario. Aerodynamic drag is not so easy to calculate in this case, but we will get back to aerodynamic drag in March, so don't worry, we will be analyzing this topic as well. Yes?
Just making sure, H was for height.
No, H is for horizontal.
Thank you.
Yes?
So is that the full distance, or that's just for like?
It's now the height. The distance will be the next step to calculate. Okay. So distance is easy to calculate. So this is the height. Okay, I will write here. And now distance. There's one very important thing in ballistics. You always have to keep in mind that you have a combination of two types of motion, vertical motion and horizontal motion, and two different sets of formulas. Vertical motion is accelerated motion, so you have all the formulas for accelerated motion, vertical, okay. Horizontal motion in this direction is constant speed. You have significantly simpler formulas, okay, but they are first of all different. The main problem that affects people's marks in this exercise sorry, is if you mix these two motions up, okay? What happens too often is that you find out, okay, my vertical speed is 50 meters per second. So what's the distance? People quite often find the maximum altitude of this movement to be 250. How they got it? Okay, they calculate the time from the correct formula and get 5 seconds, and then think, okay, vertical speed is 50 meters per second. In 5 seconds, it's 50 times 5, 250 seconds. Okay. No, because this is the accelerated motion. In case of ascending, it's decelerating motion. So you have to use this formula here, gt squared over 2, not just velocity times time. But in the horizontal motion, we notice that this is constant speed motion, so the distance, which I will call d, the distance of this motion is very simply horizontal component of velocity multiplied by time. And who knows what I'm missing? No, we ignore the drag, okay? Maybe you will notice this when I put the values. So VH is 87, time is 5 seconds. Is that all, or I am forgetting about something? Yes?
What about vertical velocity?
Doesn't apply here, okay? It's a distance is created by horizontal movement. It's what I showed you previously in slow motion, okay? If I'm finding this guy here, okay, the vertical motion tells me how it climbs and then how it descends. But horizontal motion is just a constant motion, okay, constant motion which will not change. It's all the time 87 meters per second. Okay? So if I multiply it by time, I get the distance, yes?
That's only half of this.
It's only half of the distance because 5 seconds is the ascent time or descent time. So it's like I'm flying, okay, 5 seconds, and I have this distance. Now I have to multiply it by 2 to get another half, okay? With aerodynamic drag, it wouldn't be so easy anymore because basically it wouldn't be times 2. It would be times a little bit less than 2. But without aerodynamic drag, everything that I need to add here is to say times 2 times 2, and it is equal to 870 meters. Okay, as you can see, it's quite a powerful cannon. We managed to shoot over roughly half a mile away, and the maximum altitude is 125 meters, but it was a powerful cannon. Okay, I checked this is absolutely a realistic value in artillery. Okay. This concludes the first part of this lecture. Time now is